Hi guys, there was a question from section 3.5, problem number 25. So obviously these are some application problems. So one of the really main reason why we learn derivative in this course is because derivative is one of the most useful tools in application when you're trying to find the rate of change, how fast something is changing a function with respect to the number of items. So right now we have basically two pieces of information. We're given the revenue. By the way, they're using capital R because the word revenue, of course, it starts with R. So these are all mathematical functions, but also they have business application or representation. So this function actually represents the revenue function in this problem. And also we're provided with cost function. Again, they're using C again because the word cost starts with letter C. But again, it is a mathematical function. Whatever it represents, it doesn't really matter because at the end of the day, you are going to deal with them mathematically. Okay, so these are your revenue and cost function. Let me just read the instruction or the question. It says in exercises 25 through 30, find the maximum profit and the number of units that must be produced and sold in order to achieve that. Okay, so we're looking for maximum profit. So if you remember in the last couple of sections, you learned how to find the maximum and minimum value of a function. Of course, first we have to know what the function is. So I'm going to call it P for profit. So as I'm sure you know, and if you have any kind of business mind, you probably know to find the profit of a company, you have to take the revenue and deduct the cost, right? So whatever money you made, once you take the cost from it, that should give you a profit, okay? So that'll be, and always remember this, because I'm sure you'll see a problem like that in your exam. So make sure you always remember profit is revenue minus cost, which obviously makes business sense. So now we're just going to replace the functions. Our revenue function, which is 50, x minus 0.5, x squared, and then we're going to subtract the cost, which is 4x plus 10. I'm just going to go ahead and distribute the negative so we can remove the parentheses. So this becomes 50x minus 0.5 x squared minus 4x, and then of course minus 10. So obviously 50x and minus 4x do combine to be 46x, and then minus 0.5 x squared, and of course we still have minus 10. Okay, so there is your profit function by, again, just simply using the revenue and the cost function, subtract cost from revenue, that will always give you the profit function. So now, of course, he wants to know the maximum profit. Well, once you get to the actual function, again, it doesn't really matter what function this represents, whether it's cost, profit, revenue. To maximize any function, as you learned in the last couple of sections, you have to look for the critical value. Remember, because the critical value is where the maximum minimum always happens, okay? So I'm going to go ahead and, of course, as you also know, to find the critical value, you need to differentiate your function. So we're going to differentiate our profit. Derivative of 46x, of course, is 46. Derivative of don't forget 0.5, same thing as 1/2. So the 1/2 is in front, but then derivative of x squared is 2x, and 2 times 1/2 simply becomes 1. So that just becomes minus x. So this is your profit function. I'm going to go ahead and move it up here. So now that we have our, not profit, but derivative of the profit function, we're going to go ahead and set it equal to 0. So from here, to find a critical value, which is where the maximum can happen, is going to be 46 minus x equal to 0, which of course, as you move the 46 over, it says negative x is negative 46, and then you multiply both sides by negative 1 to remove the negative in front, and that becomes, of course, x, and negative times negative become positive. So 46 units is basically what you have to produce to achieve the maximum profit, okay? So now he wants to also know, so remember there were two questions. What is the maximum profit and how many items should be produced to achieve it? So now you already know there has to be 46 units to achieve the maximum profit. Now he also wants to know the maximum profit. Actually, I just erased the profit function, but I think I have it written down, so you should be already in your video. And then that should be the last question, okay? So now we know at least at the level of 46 units is where this company achieves its maximum profit. Now, what is the maximum profit? the actual maximum profit, of course, is going to be simply taking the profit function, which again, I'll remind you what that was in a minute, and then evaluate at the number of units that will achieve it. So that's the final question. What is the profit function at the level of 46 units, okay? So let me go ahead and take you back to the profit function, which we had a minute ago. So as you simplify the profit function, as you remember, we got the P of X to be 46X minus 0.5X squared, and of course minus 10. So this was our profit function. And now we're just going to evaluate at 46. And that should give us exactly, I'm going to go ahead and plug it in and then let you do all the arithmetic there. It shouldn't be that difficult. And if you do it correctly, which I'm sure you will get the following. Don't forget, this is, of course, profit, cost, revenue, they're in dollars. So at the end of the problem, you always want to include the units, which, of course, is going to be in dollars. And as you plug everything in, you should get basically $1,048. So $1,048 at the level of 46. So the maximum profit is $1,048. And, of course, it happens when you produce 46 items, okay? So, all right. There's another question. I guess I'll make another video for that one.